Okay, pre-calc. Students, here is one more example from the packet. This is problem number 30. And so I'm just going to go through the steps to graph a rational function. For most of you, you've seen this. For the juniors, you'll see it tomorrow. But we just create this set of procedure steps to help us find what we need to find. I'll just go over these quickly, and then I'll upload this into Google Classroom as well. So factoring everything first. Looking for discontinuities, that would be either vertical asymptotes or holes by checking the denominator of the function after we've factored it. Finding the x-intercepts, letting y equals 0 for a rational function that amounts to looking at the numerator for values of x that make the function equal 0. Then we look at the y-intercepts, we let x equal 0. There should be only one of those. And then we find the horizontal asymptote on page 345 in the book. There's a discussion of the cases that could arise there. And then we use a t-chart to help us find additional points on the graph. Okay. So first thing we do is factor everything. And then we, just like in fractions, we look for things we can cancel out. Okay, there aren't any factors that cancel. And so one of the things we can answer by that is, are there any holes in the graph? Because nothing cancels, then the answer is right, no, there aren't any holes in this graph. Okay, the second thing we want to check for is, in terms of discontinuity, is the vertical asymptote. And that comes from the denominator. So we're going to check what values of x make the denominator equal 0. Since we've got it factored, right, it's easy for us to see that when x equals 1, the denominator is 0, so we have a vertical asymptote at x equals 1. So go ahead and draw that in. Okay, next we want to find the x-intercepts. So we're going to let y equals 0. So we're looking in the numerator here to find out what value of x, or values of x, would make the function value, or the y value, equals 0. And that's going to be x equals -2. So that gives us a x-intercept of -2, 0, and that's the only x-intercept of this graph. So go ahead and put that in place. And then the y-intercept, we're going to place a 0 in for the x's. So a 0 here, a 0 here. The function value at 0 then is equal to 2 over 2. One way to write that would be f of 0 equals 1. Right? So another way to define the y-intercept is to talk about what's the function value when the input is 0. The f of 0 is equal to 1. So the y-intercept is 0, 1 right here. Okay, so these are all the features so far. The last thing we want to check for is the horizontal asymptote. This is the one that's the most complex. But there's really only 3 situations you need to check for. And basically it boils down to looking at the degree of the numerator and the denominator. So what we're checking is, what is the highest power on the polynomial in the bottom and top of the fraction form. So since they are equal, the degrees are equal, they're both powers of 1 here, then the situation calls for us to look at the leading coefficients, which are the numbers that are multiplied out front, and to simply take the ratio of those numbers. So we have a 1 up here, we have a -2 down here. So the equation of the horizontal asymptote is -1/2. Again, that's just the ratio of the leading coefficients in the case where the degrees are equal. Okay, so -1/2, that's right down here. So this is our horizontal asymptote, y equals -1/2. And this is our vertical asymptote, x equals 1. Okay, so these are all the features of the graph that we need to identify. We now can see that there is a sort of a new grid created by the horizontal and the vertical axis. And we know from other behaviors of other functions we've looked at that rational functions tend to, if we just have a situation like this where there are basically 4 regions where the graph could be, once we find one of them, so we know part of the graph is over here, usually that means the other part of the graph is diagonally across. So down here, not always, but often. And we're going to test that using our XY t-chart, which is always a good tool to use when we're not sure what's going on with the graph, right? So here we're basically convinced, I think, from looking at other graphs, that this one is going to go like this. Okay, it's going to curve through the x-intercept, the y-intercept. It's going to come up on the left side of this vertical asymptote, and it's going to come in at the top of this horizontal asymptote. Okay, so we really want to know what's going on over here. So we're going to pick some values of x, like easy values of x, like 2 and 3. And we're going to see what's going on. Okay, first thing we want to find out is the graph up here, or is it down here? Okay, so we go back to our function. We can either use the original or we can use the factored form. I like to use the factored form. I think it's a little easier. In those cases, probably not that much different. Okay, so 2 plus 2 is 4 on the top. And then over here, sorry, we're going to put a 2 in here. We get 2 minus 1, of course, is 1 times negative 2 is negative 2. So we have 4 over negative 2, so that's negative 2. So when x is 2, the function value is down here at negative 2. So we do know now for sure that the function is down here in this section. Okay, and probably, right, it's going to come down like this and then go up like this. So we'll just verify that by picking another number, an easy number like 3. So that gives us 5 in the numerator. 3 minus 1 is 2 times negative 2 is negative 4. So we get negative 5 over 4. So when x is 3, the function value is negative 1 and 1/4. So it's right about there. Okay, so now we can see the behavior, this part of the graph, and continue by drawing that piece. Okay, so there's the graph sketched. Here are the values of the features that we've used several times now. And hopefully this additional example will give you some more insight into solving these. One thing I've added here that I don't think we've shown before is that another way to write the y-intercept is to write this as f of 0 equals 1, meaning that the input value of x equals 0 gives us the y value of 1, which is the y-intercept of the graph, which shows up right here. Okay, all right, so check that out, and hopefully that will help you resolve your questions about how to graph rational functions.